All right, we're going to focus today on the evolution of Earth's atmosphere now that we have read the evolution of Earth's atmosphere and taken notes and answered the questions. And so this is just a review of what information you've already learned in that reading. At the top of your timeline, this might look a little different than yours, but we really want to think about this long line as one continuous timeline of Earth's history. Down here at this end, this is about 4,600 MYBP which is the start of Earth's history. And I'm actually going to change that to become, what color should it become? It should become blue. So that's where we're going to start. And then all the way over here on this side, all the way at the end, we have present. And so there's our timeline. And we started off this school year making a timeline of Earth's history. And if we think about it, right in the middle, if this is 4,600 MYBP, right in the middle here, that actually represents the halfway point. And in this case, the halfway point is going to be 4,600 divided by 2, 2,300 MYBP, okay? There have been 3 atmospheres, and this is serving just as a review of what that reading was telling us for information. So our first atmosphere started, and this atmosphere was formed right at the Earth's creation. It took a while to actually really form because Earth was so hot. And so from 4,600 to about, and if I scroll over here, and it's kind of hard to do by typing, this one ended around 3,500 MYBP. And in this atmosphere, we had the gases in this atmosphere were hydrogen, H2, helium, He. These are really tiny gases that are in our atmosphere. Then we had some ammonia and methane. Now, these gases are not great gases for life, and there was no life at this time. It was really, really hot. Those gases were here at the formation of Earth, and we believe that they were swept away by solar wind. So if you can think of your timeline, kind of split it up in half. I should have said this. Split your timeline up in half. Make sure you've labeled 4,600 on one side and that you have labeled presence on the other side so that you have a continuous timeline. Split it in half, and at the halfway point, mark it as 2,300 MYBP. Do make sure you have your MYBP because those are your units here. And you can pause this throughout when you need to so that you can make sure yours is updated. Now, halfway through that, so from 2,300 back to 4,600 MYBP, if you go about halfway through, put a little line there. We're actually going to mark that. Well, maybe we can move this over a little. We're going to put a line there, and that's 3,500 MYBP. All right, so we've kind of split up our timeline to show the different atmospheres. And there's been, like I said, 3 versions. It's not like we have 3 different atmospheres building on top of each other. We have one atmosphere, and that atmosphere is changing. All right, so all of this wind, these gases that were here at the start of Earth's atmosphere, they eventually got swept away by solar wind, which is literally wind from the sun. It's charged particles, and those swept away because they were so light. So then we have a process called, in the second atmosphere, this starts forming over time. And there is this process called outgassing that occurs. You could almost think of this as the planet literally like farting, I guess. I hope that's memorable for you because it seems funny and weird to talk about and to make that comparison. But literally, the planet was full of gas at this time. And that gas, which is now less dense, is trying to escape. And so these gases that are stuck inside our planet escape through volcanoes and vents. And this gives us gases like carbon dioxide and water vapor. Actually, maybe I'll put water vapor first because most of the atmosphere was water vapor. And then we had some nitrogen coming out, N2. And I can, if you remember, water vapor is H2O. Carbon dioxide, it literally means 1 carbon and 2 oxygen. Then we have our nitrogen. Great. So these gases come. Now, what happens to them? Because they don't stick around forever. Well, the water vapor, I'm actually going to separate it out a little bit like this so you can organize your gases to talk about where they went. Water vapor in our atmosphere, if our atmosphere starts to cool down enough, water vapor even to this day forms clouds. So this water vapor in our atmosphere formed clouds, and those clouds eventually, because it really was so much water, 80% water, that those clouds became too heavy, and it rained, and it rained, and it rained, and it rained, and eventually that rain formed oceans. So where did our water in our second atmosphere go? Down to the ground. It formed puddles. They got bigger and bigger and bigger, and then we had oceans. Okay, so now we have all this water on our planet for the first time, and that also allows for life to start to form. And some of that life started to do photosynthesis. And so some of that life started to take in carbon dioxide, and some of that carbon dioxide was actually not only taken in by plants, but it was absorbed by oceans and the plant life, trees. It was locked away in plants and trees, underwater plants, I should say. And sometimes it was locked in rocks, like limestone, and sometimes it was even put into the shells, the carbonate shells of creatures. What happened was then we were just left with a lot of nitrogen. Nothing really happened to it. It didn't really leave our atmosphere in high numbers like water vapor and carbon dioxide did. So, okay, so now we have carbon dioxide. It's going into some of the plants. It's getting locked away. And those plants, as you all might know, they start to release a gas. They start to release oxygen. This is important because this is the start of our third atmosphere. So I'm actually going to go here to our third atmosphere. Starting around 2,300 MIBP, we have all that nitrogen left over from our second atmosphere. But now there's so much more of it. In fact, 78% of our atmosphere is made out of nitrogen. And then those plants that started taking in carbon dioxide started to release oxygen gas, O2. And honestly, folks, I've been doing this a little incorrectly. If I wanted to make this accurate, I would have to make a subscript for all of these. That's actually the proper way of writing all of these chemical formulas, and we will be getting into that very shortly. But in our third atmosphere, we start getting oxygen. And now that makes up about 20% of our atmosphere. Now that nitrogen, like I said, was a result of outgassing in the second atmosphere. And the oxygen, we believe, had two theories of how it came to be. It could have come from photosynthesizing organisms like cyanobacteria. This is literally blue-green algae. Stromato. And then we think it possibly, another theory is that UV rays separated water vapor in the atmosphere. And what that would have done was taken the hydrogen from water, separated from the oxygen, and that hydrogen, which is so little, actually escapes into space, and what we are left with is oxygen. So here we are in our last atmosphere, our current atmosphere. Will it be the last? I don't know. But most of it is made out of nitrogen. Some of it's made out of oxygen. Then we have we have other elements like argon. We have CO2. Here we go. We have methane. Just trying to make sure my formatting is correct here. Methane. Oops. We have, what else do we have? Methane, we have hydrogen, we have ozone, we have nitrous oxide. And some of these gases you've never heard of, we will be getting into them, but this is just an idea of some of the gases that we might find in less than 1% of our atmospheric gases. So here really, this at the top is supposed to be your timeline showing how Earth's atmospheres have changed.